Welcome, everyone. It's great to see you all here at our next installment in our college's new faculty lecture series. It is my privilege and pleasure to introduce our guest lecturer today, Dr. Daniel Berkhout, a visiting assistant professor in the Department of History and Geography. Dr. Berkhout, who received his Ph.D. from the George Washington University in 2017, conducts research on topics including 20th century United States business history, public policy, and corporate research and development. He has presented papers at the Policy History Conference, both on the World War II era synthetic rubber program and on commercial banking deregulation during the 1984 Continental Illinois crisis. He is currently working on a history of corporate research laboratory construction during the 1940s and 1950s. The title of Dr. Berkhout's presentation today is Formalized, Complex, and Costly: The Impact of the Post-World War II Military-Industrial Complex on Corporate Research and Development. And so it is my pleasure to present Dr. Berkhout. We very much look forward to your talk today.
Yeah, thank you for the kind introduction there. I will share my screen if we can do that. Yeah, not only thank you to Dean Macy, but also to Dr. Vaughn for organizing this lecture series, helping to set up my talk today. Also want to thank everybody in virtual attendance for spending maybe about 35 or 40 minutes here listening to me discuss two topics that have been the focus of my academic research as a U.S. business historian. The first is the so-called military-industrial complex, and then the second is corporate R&D during and after World War II. Now, I unfortunately can't guarantee that this discussion is going to be quite as exciting as the previous talk in this new faculty lecture series, which I personally found very interesting. I think it was about 2 weeks ago, we had a lecture from Dr. Adinovich about improvisational filmmaking techniques. We even had the opportunity to view a short scene from his latest film. Sadly, as you can see by the title of my talk, I can't promise that same kind of experience this afternoon. In fact, I'm going to show you some tables and graphs with numbers and data, which I understand might not be the most fun thing to do on a Wednesday in the middle of the week. That being said, I'm hoping to take these two very broad topics, the military-industrial complex and corporate R&D, and talk about how their evolution in the years following World War II is potentially relevant to higher education today, especially given the current political climate in the United States, where there are increasingly questions about how certain academic disciplines, and especially liberal arts disciplines, deliver a, quote, return on investment in a global economy. And I assume that most of the attendees on the Zoom call have some vested interest in academia, whether you're a student, an instructor, or maybe an administrator. And at the end of the day, I think there's an important philosophical or maybe even an existential question here that at times can be difficult to answer. Why do we do what we do? Why devote yourself to research, to the pursuit of knowledge and discovery and truth? Does the answer to that question have to do with some kind of material goal, right? The pursuit of a lucrative career, prestige in a particular field, or are we simply pursuing knowledge for its own sake and the intrinsic rewards that come with learning, educating, and communicating aspects of the human experience? So what I want to do today is try to accomplish three tasks. The first, I want to assess a specific characteristic of the post-World War II military-industrial complex by defining what I call the, quote, formalization of corporate research and development. Namely, in what ways did R&D evolve during and after World War II? And perhaps more importantly, when and why did this process of formalization begin? The second task I hope to accomplish, I want to consider the consequences of these changes in corporate R&D. How did the decisions made by large-scale manufacturers in the US impact the manner in which research was conducted? How did these decisions generate new products and manufacturing processes? In addition, how did these decisions impact where Americans live, what kind of work they performed, and the impact of that labor on the environment and human health? And the third and final task I hope to accomplish is that I want to qualitatively assess whether or not the formalization of R&D was a, quote unquote, positive development for the United States. And I plan on doing that by considering how these changes brought about by the post-World War II military industrial complex altered the process of innovation itself. So what I'd like to do is begin with Dwight Eisenhower's famous 1961 farewell address to the nation, during which he popularized this term military industrial complex. In fact, Eisenhower's warning about a permanent armaments industry of vast proportions garners the most attention from historians, journalists, and politicians who are concerned with the nation's growing defense industry. However, a substantial and overlooked portion of Ike's speech was devoted to what he called a, quote, dramatic expansion in basic and applied research that had made R&D more formalized, complex, and costly. It was, according to Eisenhower, a technological revolution during recent decades that was, quote, largely responsible for the sweeping changes in our industrial military posture. This technological revolution that Ike described was not unlike the dramatic changes resisted by artisan craftsmen during the early 19th century. These artisans lamented that the industrial factory was eliminating their role in the economy by introducing an assembly line that allowed for continuous production and created economies of scale. Eisenhower saw a related development in corporate research as the, quote, solitary inventor tinkering in his shop was replaced by task forces of scientists in laboratories and testing fields. Essentially, Ike worried that R&D had taken on features of the industrial assembly line for the sake of efficiency, and that because of the tremendous outlays needed to conduct complicated research on a scale that would permit firms to remain competitive in the marketplace, the government contract was virtually a substitute for intellectual curiosity. As research became more formalized and as the scientists conducting it required more funding, they entered a dialectical relationship with policymakers that Eisenhower believed would threaten American democracy. This relationship was at the heart of the military-industrial complex chronicled in Eisenhower's farewell address. Just as the nation's scholars could be manipulated by, quote, federal employment, project allocations, and the power of money, so too could a scientific technological elite exert undue influence on policymakers to secure contracts and pass favorable legislation. Only responsible leadership, according to Ike, might serve as a broker among the many competing interests in the defense industry and find what he called an appropriate balance to allow democracy to survive for all generations. So this selection from Eisenhower's farewell address, it raises the question, what exactly was this formalization of R&D? Now, the dictionary definition of formalize means to give something a definite structure or shape, or to make it more regimented. And that's precisely what large-scale corporations did during the 1940s and 50s. Managers at these firms sought to make the process of R&D more predictable. Efficiency principles like cost accounting were implemented in corporate research divisions to ensure that scientists and engineers spent most of their time conducting applied research. That is, research into products and processes with commercial applications that hopefully guaranteed some kind of return on investment. We should note here too that applied research is different than basic research, which instead seeks to improve scientific theories or better understand natural phenomena. Now, to more efficiently conduct applied research, these firms made significant investments in plant and personnel in order to enhance what we might call technical and functional capabilities. These technical capabilities refer to the actual research itself, while functional capabilities refer to the coordinated tasks needed to commercialize a new product or technology. Modern research laboratories were then designed, constructed, and staffed with hundreds of scientists in order to enhance the capabilities of these firms. In addition, not only did managers coordinate activities within these corporations, but modern research facilities themselves became a physical site in which activities conducted outside of the firm were incorporated into this R&D process. Now, these outside activities included government funding, usually in the form of defense contracts, as well as basic research that was conducted by colleges and universities. So at the end of the day, the goal for these large-scale corporations was to diversify into new product lines, especially those in promising technological sectors like chemicals, plastics, electronics, and aerospace. First mover advantages in these new technologies not only proved lucrative, but they served as a hedge against emerging competitive threats in the marketplace. Now, we might ask, why did this formalization of corporate R&D take place during and after World War II? In other words, what brought about such dramatic changes here that Eisenhower thought to spend time in his 1961 farewell address actually identifying this issue? And this question raises an interesting dilemma for historians. When we're analyzing a broad process like technological innovation or corporate R&D, what actually constitutes what we might call a paradigmatic shift? I mean, what makes a particular change significant? So Thomas Hughes, who is one of the most notable historians of science and technology, he published a book in 1989 called American Genesis. And in it, he argued that this formalization of corporate R&D actually took place around the turn of the 20th century, when great systems builders began to apply the techniques of Fordism and Taylorism to the research laboratory itself. I, however, would argue that another important moment in the history of corporate R&D took place during World War II. The manner in which large industrial manufacturers invested in and conducted research was transformed because of new and more frequent forms of interaction between government officials and private sector managers when meeting the emergency demands of the war. During and after World War II, the federal government not only became a major consumer of goods and services, but it contracted with private firms to construct and operate defense plants. Perhaps more importantly, throughout the process of wartime mobilization, industrial enterprises struggled to influence federal agencies and regulatory commissions due to the government's unpredictable administration of the wartime economy. This included the antitrust stance of federal officials, congressional investigations into war profiteering, the shortages of critical materials, price controls, patent pools, and even legal red tape that made securing military contracts a confusing exercise in navigating a maze of paperwork and bureaucracy. In fact, large corporations publicly and frequently expressed anxieties that regulation of the wartime economy would actually increase competition and reduce barriers to entry in major industrial sectors. And maybe I'm just naive here, but this was one of the more surprising things that I've run across in my research. Oftentimes, mobilization for World War II is remembered as this enormous achievement for American business. And it seemed to be a moment where cooperation between the federal government and private enterprise allowed for the creation of what Franklin Roosevelt called the arsenal of democracy. However, the historical record suggests that this was actually a very messy process. And even though American corporations expressed patriotic sentiments and they sought to convince the public that they were, quote, doing their part for the war effort, they still publicly criticized the Roosevelt administration throughout the war. So it was these challenges then that would serve, at least in my opinion, as the prime mover for the formalization of corporate R&D during the 1940s and 50s. So to better understand the formalization of research and development here, I analyzed 20 years of annual reports for each of the 200 largest US industrial manufacturers in 1948. These 4,000 plus corporate reports covered a period from American entry into World War II in 1941, all the way to Eisenhower's farewell address 2 decades later. I also searched thousands of newspaper articles, corporate and government publications, and company histories for evidence of corporate research facility construction from 1941 to 1960. This then led me to 3 conclusions. First, to alleviate concerns over the future of competition in their respective industries, most large corporations implemented product diversification strategies during the 1940s and 50s. Diversification took these firms into technologically complex product lines, thus enabling them to secure first mover advantages in emerging markets and protect themselves against the uncertainties of the post-war political economy. Second, because first mover advantages were vital in capital-intensive industries, many companies began to strategically plan for demobilization in the post-war economy immediately after the attack on Pearl Harbor. Large corporations were in a better position to allocate resources needed to diversify into new industrial sectors, And almost all of these firms had initiated diversification strategies by the time Eisenhower delivered his 1961 farewell address. And finally, product diversification demanded that manufacturers alter their strategic posture with respect to research and development. During and after World War II, corporate enterprises allocated more resources to R&D. They built new laboratories and they hired personnel to staff these buildings. An analysis of the 200 largest US industrial manufacturers in 1948 reveals that at least 189, or about 95%, pursued some type of diversification strategy from 1941 through 1960, while 153 of those firms moved their operations into entirely new industrial sectors. Of this same sample of 200 manufacturers, at least 186, or approximately 93%, constructed new research facilities from 1941 through 1960, and 45% had broken ground on new laboratories by 1948. This laboratory construction that was initiated soon after the war is notable, at least to me, because such projects were unusually expensive due to high inflation rates that lasted through 1948, as well as the shortage of labor and building materials as the country returned to peacetime production. On the surface, these strategic initiatives undertaken by large-scale corporations, they might not seem significant, but remember that these firms enjoyed oligopolistic positions in their respective industries. An oligopoly, then, it refers usually to an industry in which the top 5 firms own at least 60% of the total market share. So in other words, these large-scale corporations were price makers instead of price takers. They were largely insulated from competitive forces and new entrants into the marketplace, at least until mobilization for World War II generated these uncertainties about the political economic environment in which these enterprises conducted business. I'd also argue that the enormous risks that some of these corporations took in entering industries in which they had little or no experience suggests that there was a paradigmatic shift in how corporate R&D was being conducted. Now, this strategic repositioning of large-scale industrial manufacturers with respect to R&D, it required substantial capital expenditures that came from both the public as well as the private sectors. In interviews in corporate publications, managers and executives acknowledged that federal spending influenced their R&D strategy in the 2 decades following World War II. For example, Sylvania Electric was one of many firms to secure a share of this public funding through lobbying. It set up an Office of Government Relations in Washington, D.C. to maintain close contact with certain departments of the national government. Now, I know there are a lot of numbers on this table right here, but you can see the growing importance of federal spending to R&D conducted in the U.S. during the 1950s and early 60s. In the span of 10 years, from 1953 to 1962, the total amount spent on R&D from all sources tripled from $5 billion to over $15 billion. During that same time, the federal government's share of R&D spending rose nearly 5-fold. And by the late 1950s, the government was funding nearly 2/3 of all research being conducted in the United States. For, at least to me, for an interesting point of comparison, it's not up on this chart here, but the Department of Defense spent only $26 million, that's million with an M, on R&D in 1940. This is just on the eve of World War II. So what we're seeing here in this chart, I mean, this is a dramatic shift in public policy and the stance of the federal government with respect to R&D. We should also note that even though the federal government was funding a majority of all R&D being conducted in the US by the mid-1950s, nearly 80% of that work that was being performed was taking place in laboratories owned and operated by corporations. As a result, when we assess the evolution of corporate R&D after the war, we risk overemphasizing the role of federal spending at the expense of decisions made by executives and managers at these large industrial firms. In fact, it was these strategic initiatives that shaped the structure of the post-war political economy, and they determined where and how R&D would take place in the United States. So the most important and most capital-intensive step in the formalization of post-World War II corporate R&D was the construction of modern research facilities. These facilities were themselves small-scale, brick and mortar, quote unquote, military industrial complexes, where the technical and functional capabilities of large corporations were enhanced by managers and scientists who not only secured funding in the form of government contracts, but they also coordinated the activities of corporate and university laboratories to achieve technological innovation. The decisions made by companies while designing their research facilities reflects a phrase that was popularized by historian Alfred Chandler: structure follows strategy. Essentially what this means is that businesses tend to alter their organizational structures to better meet their strategic goals, which makes sense, right? Similarly, I would argue that the physical structures at these firms also followed their strategic initiatives. In this way, the laboratory architect played a major role in technological innovation, practicing what was called imaginative coordination to balance the stated requirements of three-dimensional space, construction materials, equipment, cost, and appearance. Many of these central laboratories and research campuses, some of which you can see right here on this slide, the ones that were built in the generation after World War II, they oftentimes had a similar appearance. They were usually 2 or 3 stories in height. They had these sleek, modernist exterior designs, and they were oftentimes surrounded by parks and trees and fountains that were reflective more of a pastoral setting than an industrial complex. During the 1940s and 50s, many large manufacturers constructed these massive research campuses that contained multiple units and employed hundreds, if not thousands, of technical personnel. Such units were often devoted to a range of scientific disciplines, allowing the company to centralize diverse R&D activities at a single location. The most common trend that I encountered in research facility expansion among the largest US manufacturers was to operate several specialized laboratories during the 1940s before branching out and establishing a research center by the early 1960s to coordinate all of these smaller facilities. Among the many corporations that followed this pattern behavior were Allis-Chalmers, the Coppers Company, St. Regis Paper, General Mills, and Sinclair Oil, which actually established a research center in Tulsa, Oklahoma in the early 1960s. These specialized laboratories included those devoted specifically to things like plastics, chemicals, engines, jet propulsion, pharmaceuticals, just to name a few topics. Automakers and farm machinery manufacturers, they operated large proving grounds to test vehicles and equipment, while firms in the lumber and paper industries set aside experimental forests where they could conduct research on land and resource management. So on this slide, I provided a diagram of one of these research centers that was built in the wake of World War II. In 1948, B.F. Goodrich opened a new suburban research complex in Brecksville, Ohio, which is about 20 miles outside of Akron. Now, I've done substantial research on B.F. Goodrich, so I'll refer to them a couple more times during this lecture. Part of the reason I'll do so is that Goodrich's experiences during and after the war, they're representative of many large-scale manufacturers during this period. Most importantly, at least for me as a business historian, Goodrich is the rare company whose internal records are actually available to researchers, right? Which is pretty important if you want to talk about developments in the past. In any case, what we can see in this diagram is a somewhat basic research center design, but one that is already carving out space for specialized R&D in both chemical and mechanical engineering, which were 2 areas of study that Goodrich was increasingly interested in as it began to slowly move away from its narrow focus on rubber and tire manufacturing after World War II. More importantly, the main research building on the left, it contained 81 laboratory modules that were 10 feet by 26 feet each, and these possessed internal walls with moving metal partitions, thus allowing Goodrich to make changes to laboratory workspace. This flexibility in the arrangement of space, utilities, and equipment ensured that resources could be more easily devoted to the study of products and processes with commercial applications. We can also see that laboratories were not one size fits all, but rather were intended to meet the specific needs of scientists and engineers who explored a diverse range of products and processes. So whether an enterprise built a specialized research unit or a central laboratory to coordinate a variety of R&D activities, Such complexes were geographically dispersed throughout the country. Because much of the nation's manufacturing capacity was still concentrated in the north, many firms opened laboratories in or near major industrial centers there. Of the 200 largest US manufacturers in 1948, about 150 of them constructed their first new research facilities after 1941 in either the Mid-Atlantic, the Midwest, or the Northeast. However, many manufacturers that had built laboratories in the North would, by 1960, also construct research units in the South and West, as these two regions experienced rapid post-war population and economic growth. Rexall Drug, for example, announced in September of 1945 that it would move its headquarters and corporate laboratories from Boston to LA. Similarly, IBM sought to take advantage of engineering talent on the West Coast by constructing a San Jose, California lab in 1952 at the southern end of what became Silicon Valley. These massive suburban campuses built by many corporations also attracted scientists and engineers who wanted to work and raise a family outside of a metropolitan area. Likewise, a suburban site allowed for facilities to be constructed in several phases as R&D activities changed over time. Enterprises carefully planned both the size of their campuses as well as the placement of buildings to ensure for the possibility of growth for many years ahead. On the other hand, the suburban research campus also contributed to the post-war problem of white flight from the nation's cities. While white-collar employment eventually became a stepping stone in the middle classes for people of color, these opportunities emerged only gradually and were, quite frankly, almost non-existent during the 2 decades after World War II, while the nation contended with Jim Crow in the South and racial prejudice in the North. That being said, the construction of these research facilities throughout the country required firms to hire thousands of scientists and engineers. Of the 200 largest corporations in 1948, there is data regarding research personnel available for approximately 144 of them. This data can be found in National Research Council's directories of industrial laboratories, which were published in 1940, 46, 50, 56, and 1960. Because these NRC directories relied on firms to respond to questionnaires and to accurately self-report information about their research facilities and personnel, precise employment figures for all of these manufacturers simply aren't available. However, of the 144 firms in this sample for which at least some data is available, these firms increased their total research personnel from at least 41,000 in 1940 to at least 220,000 in 1960, an expansion of over 400%. Included in this total were some women who, for the most part, were hired as lab technicians. After World War II, managers began to seek out women to, quote, do routine analytical work on certain laboratory problems. Now, despite their qualifications, though, these women were often relegated to menial tasks in the laboratory, since corporate managers incorrectly assumed that only, quote, a more highly trained chemist or engineer could conduct complex research. So while this dramatic construction of new research facilities provided white-collar employment opportunities and contributed to the growth of the American suburbs, it often came at a cost to the surrounding environment. A number of laboratories built by large industrial manufacturers from 1941 through 1960 were contaminated with hazardous waste and later designated as Superfund sites by the EPA. For example, Publicker Industries constructed a 37-acre distillery and research facility in South Philadelphia that was abandoned in 1988 and then later taken over by the EPA when it was discovered that Publicker had left more than 2 million gallons of alcohols, chemicals, and fuels behind in that facility. Monsanto's Mound Laboratory, which you can see right here on this slide in Miamisburg, Ohio. This was opened in 1958. It was later declared a Superfund site because low levels of radioactive plutonium had leaked into nearby soil and groundwater. In fact, nuclear accidents and improper disposal of radioactive materials at other research facilities, this costs state and federal governments hundreds of millions of dollars in this post-World War II period in cleanup costs. Some of these sites included the Jersey City Laboratory of N.W. Kellogg, Sylvania Electric's Research Complex in Bayside, Queens, and Curtiss Wright's Research Center in central Pennsylvania. This environmental fallout, in some ways, it threatens to overshadow the work of scientists at industrial laboratories. But even some of the innovative products and materials developed by these professionals had a negative impact on the health and safety of workers and the public. For example, B.F. Goodrich's development and manufacture of PVC, or polyvinyl chloride, this exposed dozens of workers at a Louisville plant to toxic chemicals that were later found to cause liver cancer. It's these kinds of externalities that must be considered when assessing post-war industrial research and its effect on technological innovation. Corporate investment in R&D might have shaped, quote, the very structure of our society, as Eisenhower had said in his 1961 farewell address, but it did so in ways that were both anticipated as well as unintended, thus impacting communities across the country. For the most part, corporate research campuses and specialized research laboratories, because they were designed for work on particular product lines, they focused on applied research. Therefore, many industrial manufacturers formed arrangements to have universities conduct basic research that would complement R&D being performed in the corporate laboratory. For example, American Locomotive enjoyed ready access to the laboratories of Union College in upstate New York, while Standard Oil of California worked in close cooperation with the Radiation Laboratory of the University of California on classified research for the Atomic Energy Commission. Other companies sponsored basic research at universities through grants and scholarships. Lockheed's Missile Systems Division offered scholarships for physics and engineering graduates who performed part-time work for that firm. Cudahy Packing established a grant that afforded the company the benefits of joint research activities with the University of Nebraska. And Cities Service Company, which later became Citgo, it sponsored chemical engineering and physics research at MIT, Columbia, Harvard, and what at the time was then Oklahoma A&M. A handful of firms even built their own laboratories on or near university campuses to take advantage of the talent pool of scientists and engineers at these institutions. And nearly every company avidly recruited students at local universities that were pursuing degrees in chemical or engineering fields. What the formalization of corporate R&D did then was implicate university students and researchers in the military-industrial complex, as well as the growing reach of the defense industry into American life. And finally, studying the formalization of post-World War II corporate R&D, it allows us to conclude that there was no singular pathway to innovation. Even among competitors in the same industry, there was some variance as to when firms constructed new laboratories, what purpose these facilities served, and what types of products were studied by company scientists. Some discoveries even came about due to accident, which is why advocates of what was known as pure science, like Vannevar Bush, you can see right here, they argued for greater investment in basic research. In his influential 1945 report to the president entitled Science, the Endless Frontier, Vannevar Bush argued that new products, quote, require continuous additions to the knowledge of the laws of nature that can only be obtained through basic scientific research. However, despite Bush's recommendations, companies continued to be driven towards applied research by the competitive demands of the post-World War II political economy. In my sample, the 200 largest industrial corporations in 1948, 14 failed to construct new research facilities during the 1940s and 50s. And for the most part, these firms often struggled to remain competitive. Among the largest textile manufacturers, American Woolen, Cannon Mills, and Pacific Mills, they all failed to build laboratories in the 1940s and 50s. And all three of these companies fell on hard times or were bought out by larger enterprises. Shoemaker, Endicott Johnson, did not increase its available R&D workspace after World War II. And by 1960, the firm announced a loss of $1.5 million, the first time it had posted such a loss in its history. So as a result, I think we can responsibly say that innovation in the post-World War II period was not inevitable, but instead resulted from the strategic organization of resources for laboratories and the technical personnel whose discoveries led to the introduction of new products and processes. Such diversity in the implementation of research strategies, it gave rise to a dynamic American economy. It was one in which R&D resources were increasingly devoted to growth sectors like aviation, electronics, and chemicals. So the implications of this increasingly narrow focus on applied research, this can be seen by looking at the experiences of B.F. Goodrich in the second half of the 20th century. And I know there's a lot on this slide here, but I'll just kind of summarize their experiences very quickly. During the war, Goodrich participated in something known as the synthetic rubber program, which was a government-organized effort to develop synthetic rubber after Japan seized approximately 95% of the world's natural rubber supply in Southeast Asia. By participating in this program, Goodrich had to enter what were known as patent pools, which allowed other rubber, chemical, and oil companies to use patents and technology that Goodrich itself had developed in its own laboratories. Because Goodrich was, I think rightfully so, wary of what the consequences of this government intervention in the rubber industry would have on competition in the marketplace, it implemented a product and research diversification strategy while the war was still taking place. As we've seen before on a previous slide, Goodrich opened a modern research campus in 1948, which it staffed with hundreds of new scientists and engineers. By 1960, I would argue that Goodrich was not just a rubber manufacturer anymore, but instead had become a diversified research company with extensive product lines in plastics, chemicals, adhesives, and even aircraft parts. In fact, by 1989, Goodrich no longer even manufactured tires. It sold the B.F. Goodrich brand to French manufacturer Michelin, and the Goodrich Corporation continued on as an aerospace company until it was acquired by United Technologies in 2012, which itself merged 2 years ago with Raytheon, one of the largest defense conglomerates in the world. In fact, we can better understand the formalization of R&D at Goodrich if we look at this organizational chart of its research division during these pivotal years from 1942 through 1953. In 1942, Goodrich established a highly departmentalized structure in its research division that improved cost accounting, and it gave executives a better idea of where expenditures might produce greater returns on investment. Each department had their own directors, their own research facilities, and their own research projects within this broader division. From this organizational chart, we can already see how Goodrich's R&D strategy was beginning to evolve as early as 1942. Departments for chemical and textile research were created to be followed later by departments for colloids or adhesives and biochemicals after this Brecksville Research Center opened in 1948. You should also note, too, that the Synthetic Rubber Research Department, it's on the left side of the screen, highlighted in green, this was disbanded in February 1948 as the company had lost its competitive advantages in this product line as a result of the patent pools created by the federal government during World War II. I highlighted one other department in green to draw your attention to it. Dr. Waldo Semin, who was at the time the most accomplished scientist at Goodrich and who actually headed synthetic rubber research at the company, was moved in 1943. And mind you, this is in the middle of the war, in the middle of the company's participation in this federal synthetic rubber research program. Waldo Semin was moved to a brand new department called Pioneering Research. Here, Semin and his team had wide latitude to work on applied research projects that had commercial promise or that captured the interest of company scientists. As you can see then, the decisions made by Goodrich managers during these pivotal years had an enormous impact on the future of the company. I mean, what was once one of the largest or four largest rubber manufacturers in the United States, it's now just another nameless subsidiary in one of the largest defense conglomerates in the entire world, Raytheon. We should also note that this experience was not unique. Other rubber manufacturers pursued similar diversification strategies, as did firms in other industries. What drove these strategic initiatives, at least in my opinion, was a competitive environment that no longer incentivized basic research or research for its own sake. An American economy that was increasingly organized around its war-making capabilities meant that firms had to anticipate competitive threats before they emerged by securing federal funds and steering their R&D activities into emerging technological sectors where products and processes could be more readily commercialized. And finally, to conclude this lecture, I'd like to ask a similar question to the one that Eisenhower explored in his 1961 farewell address when he was identifying characteristics of the military-industrial complex. Specifically, was the formalization of corporate R&D a positive or negative development for the United States? Now, as sober and rational scholars, I think we oftentimes try to avoid qualitative assessments of historical figures, events, and developments that might at times lead to maybe polemical narratives of the past. That being said, historians must assess the significance of events and developments, and one way to do that is to try to determine their consequences. So on the one hand, this paradigmatic shift in R&D that took place during the 1940s and 50s, it contributed to the Allied victory during World War II, and it allowed, for better or for worse, the U.S. to maintain its military and economic supremacy throughout the Cold War. In addition, the military-industrial complex ultimately produced, in a roundabout way, higher standards of living for Americans as groundbreaking technology like plastics, jet aircraft, personal computers, and even the internet were at least partially developed in support of the defense industry. However, there's a flip side to this coin. And it's perhaps the reason why Eisenhower warned the nation in 1961 about R&D that was becoming formalized, complex, and costly. We've discussed the environmental impact of corporate R&D. We've also talked about research campuses and their contribution to post-World War II white flight from American cities to American suburbs. Perhaps just as importantly, the very nature of research itself had changed by the 1950s. No longer was this the pursuit of knowledge for its own sake, but instead had a final end: to serve the state in order to secure federal funding. It was when research became increasingly formalized, regimented, and predictable that Eisenhower warned the nation about the effect of the military-industrial complex on the nation's public and private institutions, and particularly on its democracy. And maybe this is a way to return our focus back to the point I raised at the beginning of this talk regarding contemporary debates over higher education and the role that liberal arts disciplines should play in preparing students for their academic and professional careers. And I don't mean to make this a one-to-one comparison or even claim that the current stakes are as high as what Eisenhower warned the country about in 1961, but I think it's at least useful to consider what happens when economic and competitive environments incentivize the pursuit of one area of knowledge over another. Especially since this debate between basic and applied research, or between what we might say the assembly line and intellectual curiosity, continues, at least in my opinion, to be relevant today. So thank you very much. Appreciate your time there. So.
Okay, thank you very much, Dr. Berkhout, for a wonderful, really stimulating and challenging and very exciting talk, and very trenchant and relevant to so many issues we're grappling with today. I hope you'll all join me in actually or virtually offering a round of applause and our appreciation to Dr. Berkhout.
And I apologize for the charts and graphs and all that. Yeah, right. So, yes.
No,
I'm just kidding. Sure.
Thank you. Thank you. I imagine there may be questions, comments, contributions to a vigorous discussion, I hope. So I think at this point we can open up the floor, and Dr. Berkhout, I hope you'll be open to answering our questions.
Dr. Berkhout,
yeah, hey.
Do you see? I'm Brett Sharp in political science.
Oh, hey.
So I had that as one of my fields, science and public policy, technology policy, back in my doctoral program, and haven't really visited much since. But do you see any lessons here for like what our recent experience was with the vaccines and the medical breakthroughs for COVID?
That's a good question. One I haven't quite considered. Also, too, I focus predominantly, at least in my research, on industrial manufacturers as opposed to, maybe both, kind of firms in the medical industry. Although there was some overlap there. I think what is interesting too, and there are a number of reasons for this, is I gave that. Or provided that one table that showed that approximately by the mid to late 1950s, at least 2/3 of all R&D being conducted in the United States was being conducted by, or at least being funded by the federal government. Those percentages have actually flipped almost entirely in reverse. Now it's about 2/3 is financed by the private sector, and maybe 1/3 by the federal government. Although the vaccine here, again, as a historian, I'm always reticent to lay some kind of conclusion on something that has happened so close, in the kind of distant past, right? But it's largely been held up as this great achievement. Again, I'm not 100%. I'm not a scientist, so I don't know all the technology behind it. But it seems to, be an example here of kind of this close relationship between kind of the public and private sector. I don't mean to sound so negative, hopefully, during my talk here in terms of kind of the impact of what federal funding could do. But I think that's an important question for companies, and where does maybe public funding is the answer here to allow for more basic research into these broader questions to, if not necessarily develop a vaccine for a kind of ongoing pandemic. But this is the way in which a number of major consumer products, that we use today, such as, even the internet itself, right? We couldn't even be having this conversation right now. But that was a result of the DARPA program, which began in 1958. And one of their mission statements was to essentially fund this, this far-reaching and forward-thinking basic research. That there wasn't always quite this guarantee that, hey, whatever we're doing in the lab, we need to show that this is going to be commercialized. If not a year down the line, maybe even in a couple quarters. So. I think, I don't know, maybe there are opportunities there for kind of this, once again, kind of this close relationship, or maybe increasingly more federal funding in different forms of research and development today.
Dr. Vaughn?
Sure.
This is, I guess, a comment. My husband is a theoretical physicist who works on quantum computing, but starts with the really basic stuff. And I think this is still very much part of the landscape today for the people who engage in the basic science and pure science really want more federal funding because that's easier to get, because private companies tend to want to invest less because they're under pressure from the stockholders to get a return on their investment sooner. But this was, I appreciated your talk because this gave me a much better sense. I have some idea from the 90s and the 2000s, at least in physics, what this has been like. But it gave me a sense of how far back this goes, and also gave me a more nuanced understanding of Eisenhower's actual speech about the military-industrial complex, which I usually will see a sentence or two of, but not more of a context. So, thank you. I really enjoyed the talk.
Well, thank you. It's odd too. When I first looked at that speech, I've always been fascinated by just Eisenhower in general, but especially that particular address. It seems to me increasingly rare for a president to kind of level with the public, but this is a guy who's bowing out from from his kind of public life. But it's about, I don't want to say a third of the speech, but it's a pretty good portion that is just devoted to research and the pursuit of knowledge, and it kind of gets into some of these philosophical issues that it's not necessarily that you wouldn't expect that out of Eisenhower himself, but maybe just out of a president of the United States in general. And I should also note too, and I tried to hint at this at one point in the talk, that again, the difficulty of trying to say, oh, hey, World War II and the immediate years afterwards, that this is the moment. Again, I think I'd mentioned is Thomas Hughes writing this book, American Genesis, and there are other scholars too that say, no, actually the major part is where we start even getting corporate research laboratories in the first couple decades of the 20th century. I would argue that there's significant changes in terms of how those laboratories are organized, the thought that goes into constructing them. But you might even be able to stretch this narrative out, kind of further into the past there.
Oh my gosh. Hello, Professor Berkhout. That really was an excellent presentation.
Oh, thank you. Appreciate that.
So my name is Shelby. I happen to work in the UCO Financial Aid Office, but I'm also a student. So financial influence in our ways of thinking is really much of interest to me. But I really appreciate profiling B.F. Goodrich.
Sure.
So with your explanation of B.F. Goodrich, I could see how, say, financial influence might pressure them to guide a course for their research, but I could also see there's kind of an organic development for them to consider synthetic rubber. How does it interact with chemicals? Yes. How does it interact with adhesives? Yep. How might it be used with textiles? So they might naturally want to explore these different avenues of research. So again, okay, applied research and basic research. Yeah, the applied research has a heavily financial influence to it, whereas basic research maybe you could think of as wasteful or inefficient if it doesn't have a specific financial valuation, and see how that relates to us students and our studies. Does my education have a technical and applied valuation, or do I have a basic education that maybe is more unknown? Those parallels were very striking to me. And so I'm sure you could point out instances in your research where financial valuations heavily influenced decisions that were made. Do you have an example that you could provide for us?
Oh yeah, I mean, it's almost every one of these firms. It's usually competitive pressures. It's also interesting too that the kind of the period that I studied not only deals with World War II, but then just 5 years later, you get into Korea, and many of these companies are dealing with the same problems once again. I'm trying to think off the top of my head. I know I had mentioned American Woolen. This was one of these companies, one of the 14 companies that did not expand their research facilities, but they tried to make a last-ditch effort before they were bought out by a competitor by trying to move from essentially the production of wool into synthetic fibers and yarns. And at that point, it was just too late, right? They kind of misread where this competitive environment was going. But yeah, I mean, the majority, and the point that you made before about Goodrich and kind of this close relationship between, okay, yeah, you're studying, rubber manufacturing that deals with chemicals. You can get into, again, plastics in particular, this kind of polyvinyl chloride that Goodrich began to sell in the 1950s and 60s. A lot of these firms stay close to what we might call kind of their core competencies, but there's others that, for whatever reason, and it'd be interesting to get into the archives of these firms to figure out where these kind of pathways of innovation actually originate. But there are other firms like, and including in the rubber industry, General Tire and Rubber. This is one of my favorite ones. They bought up after World War II. They bought RKO Pictures, right? They have no expertise whatsoever in operating a movie studio. They get into aerospace engineering. They start selling refrigerators. So there, I don't. There must have been some manager who said, oh, hey, there's going to be a market in this, right? So that would be this kind of, very narrow kind of applied research and this coordination of kind of capabilities to steer the company in that direction. But, for the most part, I think it's at least initially, it's kind of these core competencies. You have oil companies, for example, that get into chemicals, get into synthetics and plastics, essentially are no longer oil companies, but really kind of chemical companies in a way. So that's where I can see kind of this overlap too between probably basic research, especially that was even being conducted before the war itself. And hey, we have somebody in our laboratory that's an expert on this particular topic. Maybe we could start to steer some more resources in that particular direction. So it would help, and again, this, I think I hinted at this during my talk. One of the reasons I focus on Goodrich is because that particular company was eventually bought out. Nobody bothered to scrub their company records that are on file at the University of Akron Archival Services, as opposed to just about every other company you look at. Somebody has gotten in there, and all that's left is just marketing materials, which again, you can write interesting histories about, but it doesn't tell you how the company actually works. It doesn't tell you these decisions that you're talking about where, okay, what is the economic rationale for how this company is going to behave, how managers are going to behave? Because in some of these cases too, it's just one of these decisions that pushes these firms in totally different directions. It could make or break the firm, maybe not, a year down the road or even a decade, but maybe several decades down the road. So yeah, I don't know. I think there are a lot of kind of interesting ways to take this. Again, I suppose every historian says this, they're frustrated with the lack of materials that are available at a given moment. But I think with more, kind of access to those kind of archival materials, I think you could better maybe answer the question that you have there.
Well, again, I just think what you provided gives us so much to think about.
Mhm.
And my other
you.
final thought for you, with my background in finance, I also have a background with data analysis and cybersecurity.
Oh,
So I
interesting.
love the charts and graphs.
Okay, sorry. It was such a stark contrast to the, as I was mentioning, the presentation 2 weeks ago, which was wonderful. I love the, talking about improvisational filmmaking techniques, but a little bit different than
It's
a
a
bunch of data
wonderfully
being
designed
thrown at you.
presentation. It's very well
Thank you. I
done.
appreciate that.
Yes.
Appreciate that.
Daniel, I'm sorry to interrupt again, but
No.
so I did some research on the Grace Commission, which was that with the Reagan initiative, where they got all the Fortune 500 leaders, the titans of industry, to come in and analyze the American federal government.
Mhm.
And they issued some reports, and I did something based on, it's kind of based on text, connectivity-based cluster analysis. It's kind of like factor analysis.
Sure.
Anyway, so I'm going to send you
Sure.
something that surprised me, and it was, and it's a little bit suspect because this stuff is not digitized. And so, I did an optical reading of one of the reports. Anyway, what jumped out at me was how much the Grace Commission was focused on research.
Mhm.
And listening to you talk sort of helps explain that. But I'm sending that to you now.
Oh, I appreciate that. Thank you very much. Yeah, and I apologize. My narrative here and much of my research focus, because it was pretty extensive to go through these thousands of corporate annual reports, which themselves are very, very interesting documents. They serve to deliver information, but they also serve as marketing materials. And guess what? Every one of these companies, they want to brag about their new research facility, right? They want to brag about the new product line. So it's actually something that the companies will tell you, hey, this is what we're doing here. They don't really have all that much motivation to really lie about it. But yeah, I haven't extended this narrative here further into the future. I think business historians too are currently struggling with having some kind of synthesis, basically, right, to bring this story, especially past the 1970s. I think there's this emphasis in business history that these firms all become conglomerates in the 1960s, and then they have to sell off some subsidiaries in the 70s once you get stagflation. There's all these other competitive pressures. But once you start getting into personal computing and what that is doing to the broader economy, yeah, there's individual, kind of narratives on certain industries, but not yet that broader synthesis like an Alfred Chandler, for instance, provides of kind of the development of American business, especially prior to World War II.
Thank you, Dr. Berkhout, for a really, really fascinating presentation and raising a lot of questions that, well, we touch on all the time when teaching these U.S. history courses and even our 1,000 level courses, etc. I wanted to ask one question, and maybe it's a loaded question.
The best kind, right? Yeah, sure.
Yeah, I was going to say it's not surprising.
Right. Sure.
Capitalism.
Sure.
Right.
Yeah.
So, in what ways is capitalism, is this conceptualization of scare quotes free market capitalism, right, absorbed or amoebaed by these types of industries in the aftermath of the Second World War, right? Where is, you're describing this incestuous relationship between private industry and the U.S. government, right? Is there any sunlight between the two things?
Between the public and private sectors, is that what you mean?
Yeah, exactly. Yeah.
Yeah, I think it becomes increasingly incestuous over time. I think, though, during, I was kind of hinting at this a little bit, during the war itself, this notion that this is an arsenal of democracy, that everybody's getting along, that there's this overarching conspiracy here, the so-called power elites, like a C. Wright Mills would say, or something like that. I don't know. It just doesn't. These firms are even in their corporate annual reports is saying, boy, the Roosevelt administration is doing this. Yes, yeah, we're doing our part for the war effort, but that being said, government is really getting in the way here. And that's something, again, it's just something so, and maybe I'm naive, but something that was so surprising to me, because nowadays companies would never say that, especially in the midst of a crisis. They'd be, kind of putting on this kind of public relations front. But these firms are trying to express to shareholders, to the general public, that hey, there's real problems in terms of how this war mobilization is taking place, that it might have unintended consequences into the future. And I think some of this too comes out of the fact that these big businesses they're not part of this New Deal coalition, right? That there's already this kind of antipathy here. And just because we get the attack on Pearl Harbor, it doesn't mean that everybody forgets the politics of the last, I mean, it's not just the last 10 years, we can go back, further and further here to wherever we see the origins of this kind of, democratic liberalism, maybe. So yeah, I don't know. Eventually though, these companies become so reliant on this kind of federal funding that they're willing to put aside maybe some of the qualms that they have, maybe some of the complaints that they have with specific mobilization programs, and in particular, antitrust. Literally, I mean, I shouldn't say literally, almost every single one of these companies that I looked at, almost every single one of the 200, experienced either an actual antitrust lawsuit in the 1940s and 50s, or at the very least a threat of an antitrust lawsuit. And a lot of times these ended up with these kind of consent decrees where the company wouldn't, it's funny, they don't exactly admit guilt, but there's usually something they have to do. And generally it was to share their own R&D, their technological know-how with competitors, right? Essentially move away from whatever anti-competitive behavior that the government had identified. So I think especially in antitrust, that there's, that this isn't this kind of tight-knit conspiracy, which is oftentimes what we think of when you hear a military-industrial complex. I mean, the term itself sounds spooky. There's some power elites that are up to no good here. Again, I think at the very least, the formation of this is much more messy than what we think about in our kind of popular consciousness, maybe.
Thank you so much for that answer. Yeah, I think that many folks on the left do imagine a sort of military-industrial complex that is, monolithic boogeyman. But thank you.
Sure.
Appreciate it.
Okay, well, thank you all for being here this afternoon. Thank you, Dr. Berkhout, for a great presentation and a great conversation, which is always a sign that it's been a really good presentation.
Well, that's good.
So, applause, and thank you all for joining us. Take care, everyone, and have a wonderful afternoon.